section 4.2 of chapter 5, video part 2. It says solve the equation algebraically. Well, in order to solve equations that are exponentials, you got to get their bases to be the same if you can, and then you can set their exponents to one another. Basically, if b to the m equals b to the n, then m equals n, right? We don't have to worry about doing that. And here's why. Because we're using a graphing calculator, we put this in y1. Well, get back to my thing. We put this in y1 and this side of the equation in y2, and we're going to see where they intersect. And that's going to give us our solution. So we've got 3 to the x plus 2 equals 9 raised to the 6/5, right? So we go type this in our calculator. Get this back up. Clear. Y equals, yep, okay. 3 raised to the x plus 2. Now, mine is putting it up here in math type, but when you hit that caret top to put it up into an exponent, if yours doesn't use math type, it'll bring up in a parentheses, which you would need to put x plus 2 and then close parentheses. Okay, and then the other side would be 9 to the 6/5. So 9 raised to the 6 divided by 5. Yep, I can just hit graph. I'm using my limits from my previous problem, which is -1 to 5, and it's kind of doing some stuff there as far as the y's. But I'm looking for the intersect. So second trace 5, enter, 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 and it's at point 4. Well, I got that. When I got that right. Let me go back. When I got that. Okay, graph. Second trace 5. Okay, enter, enter, enter. Okay, I don't know. Something just kind of popped up, so I just wanted to make sure what it was. So basically, what I have is that my answer is 0.4. It's the x value here, right? 9 to the 6/5 is 13.966. Okay. Now, before the advent of antibiotics and outbreak of chloria, I guess that's how you pronounce that, might spread through cholera, might spread through a city, so that number of cases tripled every day. Not every day, every 8 days. So tripling every 8 days. So we got something happening over so many days, right? 26 cases were discovered on July the 5th. Write a function for the number of cases t days later. Well, 26 is how many we began with. It tripled, so my base is 3. My initial amount is 26, so that's times 3, right? Now, it happened to do every 8 days, so t over 8, right? I'm going to make that t a little bit better. All right, so now we're going to graph this, and we're going to put our x's from 0 to 70. Okay, so go to our graphing calculators, hit clear, y equals, clear, go back up, 26 times 3 raised to the parentheses x divided by 8, close parentheses. Pretty sure that's what, 26/3, yep. Now, we're going to hit graph, and we've got to do this for, let's see, 0 to 70. So let's go look at our window limits. 0, 70, and I'll have it step, gosh, 10 would be fine. It could have put 5, that'd have been good too. If I hit graph, it's not going to show me anything. Okay. If I go zoom 0, what it does is it takes those X values and it says, okay, for the X values 0 to 70, I'm going to give you every output. I'll scale your Y's for you. And that's what we're doing. So what I'm going to do is go back in so you can kind of see the Y min happens to be 26. So I'm going to put negative 100 and then hit graph. Boy, it didn't show anything, did it? Let me go back in. That is 388,851. So let's go minus 1. Uh-oh. Get on the right thing there. Clear 1, enter. Let's go negative 100,000. There we go. Graph. So it kind of showing me a little bit of the fourth quadrant there. Now let's go see what they said. When should hospitals expect to be treating 56,862 cases? So that's a T. Okay. So T equals 56,862. So all I have to do is this. I just need to evaluate it. So I don't even know why they want us to graph it other than see it. Let's look at something real quick. Just want to make sure. No, that's not a before. Oh, no, sorry. My bad. That's not a, that's my output. Yeah. So my Y is that because this is my initial amount right here, which is really my Y intercept, right? So 56,862. So what I need to do is go Y2 is 56,862. I think that's right. Yeah. Yeah, 56,862. Now hit graph. And now I just want to find an intersection. So second trace, 5, enter, 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 again. And it is at 56. So T would be 56 days. Okay. Outputs was cases. Okay. All right. Okay. So we're going to do this one. And all right. A television set loses 20% of its value every 3 years. Write a function of television set 2 years after it was purchased if it cost $90 or $900. So 900 is the original. It loses 20% every 3 years. So base is 1 minus R. So 1 minus 0.2, the base is 0.8. It's got to be a decay, right? Less than 1. So the equation would be 900 times 0.8 raised to the, let's see, it does it every 3 years. So T divided by 3. And now that's a power. Okay, that's not up. That's a, let's see if I can move. No. Yeah. Come on, baby. There you go. That's a T over 3. So you write that down here. 900 times 0.8 T over 3. Okay. Now, so T has to be input years and output is how much it's worth. So how long before a $900 TV depreciates to $368.64. So it's just like the previous problem, except it's a decay. So let's clear this. Y equals 900 times 0.8 raised to the parentheses x divided by 3. I'm going to hit graph. And they told us, let's see, 0 to 20. Okay, got to go back here. Got to go to window, 0, 20. Hit graph. Then we'll hit zoom 0 because I've got a set of basically x values from 0 to 20. I just need for it to scale my y's, and that's what happens there. Now, 368.64. So that's going to go into Y2, 368.64. I think that's it, right? Yep. All right, so that's going to draw me a horizontal line, I think. Well, let me see something. I know what I done. I didn't do 900. I done 90. So let me do this second insert. 900. Hit delete. Delete. Okay. All right. So be careful when you type this in. And I'm gonna have to do it again. So zoom 0 to really get it. There we go. And it's now it's putting that line. So second trace 5, enter, 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 and that's at 12. So in 12, let me go back here. That would be 12 years. Okay, 12 years, $368.64. Now, let's look at, all right. Let's look at this one. It says decide whether the function is an exponential, a power function, or neither. Okay, so let's talk about an exponential. It's some base raised to a power, and that power has to be the variable, right? That's for an exponential. Now, a power function is this: x cubed, x squared, x to the first. The base is the variable, okay? And if you don't see that, then um, then it's neither. So let's look at this. W, yep, it's a power. See that variable is down in the base. All right, this one is exponential because the base is 0.5 and the power's up in the exponent. Power function because the base is a variable, and then this one is also a yeah, I'm pretty sure it's power. Yeah. So should be okay on that. Just in case they're not liking that as a power function, they may want none of the above. So just know that it is a power. But they may go be splitting hairs saying, well, that's quadratic, so it wouldn't be a power function by definition. So if they don't take D being a power function, then just put it C. All right, so let's look at this one. You're going to have to graph these, and you'll be able to see that this one will be steeper as it goes up like that because the base is 3 and this base is 2, and then you'll have decays here, right? So I want to just kind of you put your x, so that's -1, so it'll be -2 to 3, so x min and x max, and step it by X scale needs to be 1. And then let's put our Y min at -1, Y max at 10. 1, 2, 3, 4, 5. Yep, and Y scale 1. If you graph these, all 4 of these at the same time, you'll be able to, and there's 4 graphs for you to choose. Really, what you ought to be doing is just graphing these 2 and then turn around and graphing the decays. You just, and that way you can determine which one's steeper. You can put that and then Y1, that and then Y2, and look at them. Graph Y1 and then graph Y2, and you could pick out what's what. Okay, but that's really it for chapter 5, section 4.2, part 2's video.